Today I am at Hoover Dam. Hoover Dam was one of the many projects funded by the federal government in order to end the Depression of the 1930s. Not only is Hoover Dam notable for the way it was constructed, its design, and its location, but the rocks and the Colorado River below. I hope you enjoy my short tour of Hoover Dam and Lake Mead.
Okay, hello everybody, good morning. For those of you not on my elevator, my name is Jack and I'll be your guide for the power plant tour today. On this map, the visitor center is right about here. So we all traveled down 537 feet through the rock of Black Canyon and then walked through the tunnel just now to reach this room over the 30-foot diameter penstock pipe that y'all probably noticed outside the window when you came down. Construction for Hoover Dam started in 1931. And one of the first tasks that the workers needed to overcome was to divert the Colorado River. This was accomplished by building 4 diversion tunnels, 2 here on the Arizona side and 2 on the Nevada side, each of which is about 4,000 feet in length and 50 feet in diameter, once lined with 3 feet of concrete. If you look up, you can see that original concrete right now. So we are in one of the diversion tunnels. An upper coffer dam, or earthen dam, was put in place, and that was to encourage the river flow into the new tunnels. And a lower coffer dam was built to prevent the backup of the river into what would become the dry construction area of about a half mile. So we'll get to that in a minute, but they put another generator online just right now. That's what that water rush is. Let's see. So, after they had diverted the water, they needed to dig down through 135 feet of sediment in order to reach the bedrock, and then at that point they could begin placing the concrete. This started on June 6, 1933, with the first 8 cubic yard bucket of concrete arriving at the dam site. Just so you know, 8 cubic yards of concrete, that's roughly enough to fill up a cement truck. So from there on out, 24 hours a day, 7 days a week, every 90 seconds, non-stop, they are placing that concrete until the dam reached its present height of 726 feet in just under 2 years. So now there's about 6.6 million tons of concrete within the dam. And with that much concrete, you can build a 2-lane highway across the entire continent from San Francisco all the way to New York City. Ooh, right here, a lot of concrete. All right, so next step is going to be to fill the lake. The workers closed off 3 of these diversion tunnels, keeping the 4th open for the continued flow of the Colorado River to downstream communities. This only started in 1935, once they finished the dam, and it took 6.5 years for the lake to fill, becoming the largest man-made reservoir in the United States. Once the power plant here was ready to take on water, they could then close off that 4th diversion tunnel. So now each of these is sealed at its entrance with a 50 by 50 foot steel bulkhead gate, and each tunnel has a 400-foot concrete plug within it. So now these yellow stretches are no longer in use. However, the remaining outer stretches of these diversion tunnels, this is where they connected the new spillways to. And you can see that better on the diagram to my far right on the wall. The new spillway tunnel comes down to connect past the tunnel plug and then reconnects to the last 2/3 or so of the old diversion tunnel. And these were put in place just in case the level of the lake ever got too high. They didn't want the water to go over the top of the dam because it would flood out the power plant below it. And they've only been used twice. First time was in 1941 as an operational test, and the second time came in 1983 when record snowmelt from the Colorado Rockies rose the level of the lake here to within 7 feet at the top of the dam. So this activated those spillways, and it took 62 days for the water to be all discharged, returning the lake levels to normal. Picture behind me here, to my left, is from that 1983 event. That's what an active spillway looks like.
So how low has the level got during droughts and stuff?
I can talk about that in time.
Okay.
As far as the remaining inner stretches of these diversion tunnels, this is where they connected the penstock pipes up to the lakeside intake towers. So water can come into the towers through cylinder gates and then into the penstock pipes themselves. And you'll see that water is going to fall about 200 feet within the tower, so it's already gaining momentum with gravity until it reaches a speed of about 96,000 gallons per second. So you can feel the vibration in the floor in this room right now as well. So that is the water moving through the penstock below us at that rate of 96,000 gallons per second. That rush you felt means they opened up another butterfly valve to put another generator online of the 8 that we'll be seeing up top. And so when we get up there, you can see how many lights are on at the top of each unit to see how many units are online. Typically it's about half, so maybe 4 will be online at this time of day. And they'll continue to put everything online until it gets to about midday. And that's when they need all the energy they can get, the electricity. So from that 30-foot diameter penstock, the water can then be diverted into 13-foot diameter penstock pipes where it goes down to the power plant generators that we see here as the red dots. And so at our next stop, where we'll be viewing the generators, we'll be standing right about here. So we'll have a chance to see all eight on the Nevada side. Before we depart this room, I just want to point out the black pipe above your head. This is where that nice fresh air is coming from. It's being pumped in from the outside, and then every once in a while that pipe is diverted around the penstock below us to be cooled by the lake water. So if we were to go swimming in Lake Mead, it's probably about 80 degrees at the surface, but where they take it in Sweetwater in the middle section, it's about 52 degrees. So that air can be cooled by that nice cold lake water, and then it's pumped up through the elevator shaft, so we have nice circulation down here. It's quite comfortable, isn't it? All right, so if you can wait for me, I'll be the first one out the door, and I'll lead y'all back down through the tunnel. And I would like to welcome you all to the Nevada side power plant for Hoover Dam. We are looking at 8 commercial generators, each of which is capable of generating up to 130 megawatts of electricity. And that's enough to power about 65,000 homes. On the Arizona side, we have an additional 9 generators. So if all 17 units were online at the same time, the combined output for the facility would roughly be 2,080 megawatts, which is enough to power nearly 1,300,000 homes. Each generated water wheel generator, and it's one of 2 that we have on site, the other is on the Arizona side. The Pelton is capable of generating up to 2.4 megawatts of electricity. That may not sound like much when you compare it to the larger commercial generators, but the Pelton is responsible for all in-house power here at Hoover Dam. So that means it supplies the electricity we need for all power plant, dam, and visitor center operations.